Non-metals. In this module, we will discuss about non-metals. Non-metals. There is no specific definition for non-metals. However, on the basis of physical and chemical properties of a substance, it can be determined whether the substance is a metal or a non-metal. The common characteristics that can help in determining a non-metal are reactivity, conductivity, melting point, boiling point, ductility, and malleability. Elements from Group 1, Group 14, Group 15, Group 16, and Group 17 in the periodic table are nonmetals. Reactivity Group 1. Each nonmetal from this group has a single electron in the outermost shell. The reactivity increases as we move down in the periodic table because as we move from lithium to cesium, the affinity of the nucleus towards the outermost electron decreases. The examples of lithium, sodium, and potassium will help you understand that when there is an increase in shells, the affinity of the nucleus towards the outermost electron decreases. Reactivity Group 14. Elements of this group form covalent bonds with hydrogen. Carbon forms a large number of hydrides known as hydrocarbons. Silicon and germanium form hydrides of the formula MnH2n plus 2, where M is equal to silicon, N is equal to 1 to 8. M is equal to germanium, N is equal to 1 to 5. Hydrides of silicon are called silanes and hydrides of germanium are called germanes. Tin and lead form one type of hydride only, SnH4 stannane and PbH4 plumbane. These elements form halides in combination with halogen. General formula is tetrahalides MX4 and dihalides MX2. They form two types of oxides, monooxide and dioxide, except for silicon. Reactivity of Group 15. Forming hydrides. The elements of Group 15 form hydrides of the type MH3. They are NH3 ammonia, PH3 phosphine, ASH3 arsine, SBH3 stibine, and BiH3 bismuthine. Forming halides. The Group 15 elements form two series of halides of the type MX3 and MX5. Nitrogen does not form pentahalides. Forming oxides. Nitrogen forms 5 oxides. They are N2O nitrous oxide, NO nitric oxide, N2O3 dinitrogen trioxide, N2O4 dinitrogen tetroxide, and N2O5 dinitrogen pentoxide. Other elements of Group 15 form two types of oxides of the type M2O3 and M2O5, where M is equal to P, Sp or Bi. Reactivity of group 16. Formation of hydrides. All the elements of group 16 form hydrides of the type H2M, where M is equal to O, S, Se, Te or Po. Formation of halides. Elements of this group form a large number of halides, monohalides of the type M2X2, dihalides of the type MX2, tetrahalides of the type MX4, and hexahalides of the type MX6. M is elements from group 16 and X is FCl, Br, Formation of oxides. They form mainly three types of oxides: monooxide, dioxide, and trioxide. Reactivity of group 17. Also known as halogens, elements from this group have high oxidizing property. They are highly electronegative and are able to accept electrons. Formation of halides. Halogens combine with metals, non-metals, and even noble gases to form halides. Formation of hydrides. Halogens combine with hydrogen to form covalent halides of the type HX, HF, HCl, HBr, Hi. Conductivity, melting point and boiling point, ductility and malleability. The table gives you an idea about conductivity, ductility and malleability, and the general appearance of nonmetals. Melting point and boiling point are low. Summary: nonmetals are reactive and form hydrides, halides, and oxides with other elements. Non-metals are found in solid, gaseous, and liquid state. They have poor conductivity, unlike metals. They are neither ductile or malleable. Non-metals have low melting point and boiling point.